Just give me 1 second.
Not a problem.
Oh, it's recording. Go ahead.
Okay, welcome back to our webinar series. Again, we're going to be talking today about Windows. Just sort of a brief introduction. This particular photograph is in the Chippewa community, which is on the western side of the Quebec-Ontario border. We were up there, John and myself, John Kudrowski, and we were doing some training, and we were talking about siding, windows, doors, and roofing, amongst other things. So this was an actual on-site renovation that we were helping them sort of get a handle on and get a better understanding about, proper installation of materials such as this. So basically, as an introduction, as you can see on the slide, when you install an R2 window and an R30 wall, we've created another energy hole. Last week, I talked a little bit about doors, and doors being another energy hole. And I call them energy holes because we're basically losing a lot of our, we'll call it heat and energy, through these passageways, these openings in the building envelope, the outer skin of the building, so to speak. So windows and certainly frames, and as I mentioned earlier, doors are generally the poorest performing components of any building envelope. So windows can cause a great amount of heat loss during the winter. In northern climates, sealing out the cold is certainly a primary concern. Unfortunately, windows can also be a source of other technical concerns. Additionally, how well a window is installed certainly provides another related concern, because if it's not installed properly, there could be obviously a number of other issues that can occur. But luckily, issues with windows can often be avoided if special consideration is care is given, certainly at the design and planning stage, and equally as important, also at the installation stage. So what we're going to present here is windows being an important detail, and basically a little bit about the background on windows and maybe the selection of windows, on how best to install them and thinking about windows in general. So as a few point, there's many types and sizes of windows, and sometimes that can get very confusing. What's the right window? And hopefully I can help clarify a little bit of that in this short little webinar. When we think about windows, and certainly things like doors, they provide natural lighting and ventilation, and certainly they offer a spatial quality to, let's say, the outside, we'll call it, look of any house or any building. But a couple of things we must also think about is it must provide a weather-tight seal when closed. Otherwise, we're going to have a lot of, we'll call it warm or heated air escape out through that opening. It must have a reasonably good insulation value, and it must resist the formation of condensation. We don't want to see a lot of frost and condensation occur, certainly on the back of windows or the inside of windows, causing potentially other problems. This slide here presents a number of different types of windows by operation. So when we think about the types by operation, as we can see, there's the fixed one that does not open, the casement, a fairly popular window nowadays, has 2 operating sashes. The awning, maybe not so common. The hopper, which is probably even less common. The sliding window, fairly common. Certainly the old traditional double hung window. And sometimes we might even think about and run across some called the European tilt swing type windows, where they both swing to the side and also can be hinged at the bottom and operate almost like a hopper style window. And then one of the more recent ones is one that's considered, and again, not so common, is the pivoting window. So again, the type of window can affect the amount of air leakage and subsequent heat loss. Generally, windows with compression seals provide greater air tightness than this with sliding seals. So again, when we think about windows such as casement, we think about the compression factor of getting a better air tightness seal. Sliding, depending on the seal between the two panels of glass. Again, we have to think about how well is it sealed at the connection point between the two panels of glass. So again, some more food for thought. Again, a little bit of background on, let's talk about a few of the window elements. So there are multiple ways to insulate windows. One common way is consideration of 2 or more panes of glass. The other is to fill the space between the panes with something like an argon gas. And if we kind of look over to the right-hand side, we can see, you know, the common terminology that refers and references windows when we talk about the various elements. So the head or the sill of the window, top or bottom, more or less on the side, we expect to see the jambs. And again, some of the other terminology where we might have panes of glass or panels of glass divided up with what's called muntin bars, okay? So again, just to get you a little bit familiar with some of the terminology. Certainly that's not all of the terminology we could encounter. Again, another point is modern windows with insulated glazing units, IGUs, they're sometimes abbreviated as, consists of multiple layers of glass that are required to meet the thermal efficiency requirements in the National Building Code to a specified thermal U value. Again, over to the right-hand side, we can see to the left that window cutaway section showing two, we'll call it panes or panels of glass, sections of glass, and the one over to the right basically being our triple glaze, so 3 glass panels in that particular window. So again, just to try and get you a little bit familiar with some of the, we'll call it terminology. One of the key things when we're looking at windows or we're thinking about buying a windows, as an example, I'm thinking about replacing all the windows in my house. So that's going to be, you know, certainly part of what I need to do is do a lot of research and thinking about certainly a number of different factors when we're talking about windows, whether it's for a new build or even replacements. So things that we need to think about certainly are things about how energy efficient are those windows going to be. Certainly, I always equate better windows, higher prices, but also I have to think about the, you know, the long-term efficiency when it comes to how much is it going to cost in heat loss, where I'm going to have to make that energy loss up in basically higher, we'll call it, I guess, bills. So the energy efficiency rating, this is a common look of a label. And just to kind of break it down, if we take a look to the right-hand side, we can see the energy thermal performance values offered in that, we'll call it the upper portion of this particular, we'll call it panel. So it says Energy Star Map shows zones in Canada that products meet or exceeds, in this case, all areas. They talk about an ER number or a U value for those areas that specify values to meet an energy code. Later on, I'm going to talk a little bit about, we have different, we'll call it climate zones within Canada. And certainly the further north we go, the more we have to think about certainly the energy efficiency ratings, those differences. If we take a look over to where it's going to point, and I'll try and point over here to 0.17, the U factor, okay? So want to look at those numbers. And we could also look at things such as what's the solar heat gain? How much solar heat gain? What's the coefficient? And some of the other performance ratings. So for example, the visible transmittance and the condensation resistance. And there are sort of the testing or ratings shown in the lower panel, the weather performance ratings. So again, we're going to touch a little bit on some of those ratings and get a little, hopefully, better understanding of what we need to look at when we're kind of looking at, well, even on the procurement side, replacement or perhaps purchasing for the installation of new windows in a new build. Again, some of the performance metrics, looking at it from another label. Again, the window can be rated using ER. ER is the energy rating. The U factor, okay, which is the heat loss. SHD, the solar heat gain coefficient rather. And certainly another very important issue is the air leakage. So when we take a look at these, all of which are essential in meeting building code requirements. To comply with these requirements now and in the future, the manufacturers may need to re-engineer their products to effectively strike a balance between these performance metrics. So again, just another example. And again, we can see it's an Energy Star rated for zones 1, 2, and 3. And it's got the information. So when we're looking at windows or even doors, we should be looking for what are the performance metrics when we talk about the, purchasing or basically replacement of windows and doors. Sometimes we run across this term called Energy Star certified homes. And we can see over in the upper right-hand corner, the Energy Star, their specific logo, okay? So the Energy Star certified homes have common features, such as energy efficient windows, an HRV to recapture lost heat and provide outdoor air, and 400 kilowatts per year of electrical savings, which are typically obtained through Energy Star certified lighting or appliances. Additionally, Energy Star certified homes must meet certain thresholds for air tightness. Again, Energy Star certified homes also have several elements that will differ from basically from house to house or home to home, such as the level of insulation, the efficiencies of items such as the water heater, and the extent of air tightness. Again, what we have to think about when we think about windows and doors, I call them energy holes. And again, I indicated I call them energy holes because that's where we're going to get the most significant amount of heat loss, particularly in the, we'll call it the heating season, transferring from the inside to the outside. So when we talk about the building science portion, heat travels from, we'll call it from the warm or warmer side and wants to move towards the colder outer side. So it makes sense that we want to make sure that those energy holes are well sealed, and perhaps even just as much as importance is what's the energy performance ratings of those elements, components that we're putting into those openings, such as the windows and the doors. So again, this little diagram, heat flows through the windows in many ways. So we can see towards the top, we get solar heat gain. So we capture some heat from the sun naturally. And it can help heat up the interior space to some degree. But we also can see a lot of those, we'll call it burgundy or reddish arrows, where we can see they're going from red to blue, which means we're going from heat to blue to cold and losing that heat to the outside through a number of different pathways. So there's many ways that we need to think about sealing up a house, and certainly when it comes even to windows and doors. So what are some of the code requirements? I know everybody's not code experts, but when we look at the National Building Code, which is, I like to call it the minimum legally acceptable standard to build any building to, we have to think about what does the building code require? So the building code introduced energy performance tiers for both new construction and also for renovations. The tiered code, if we think about climate change and these, what they call tiers or steps, we're trying to move towards what they call a tier 5 or a fifth step of trying to increase energy efficiency and sort of move towards a whole other topic called net zero. So if we think about these aims to reach these goals, well, currently Energy Star standard homes are being built to meet at least the tier 3 standards. But over the next while, these steps will be increased to step 4 or even to step 5. So additionally, by 2025 or 2027, the Energy Star targets a maximum U factor of 1.05 or an ER, energy rating factor of 40 by 2030. So the building codes aim for a maximum U factor of 0.82 or an ER of 44. So just kind of give a little bit of clarification, 1.05 and 0.82, the lower the U factor, the better the window is at preventing heat loss through that particular window. The 2020 code focuses on redesigning for the 2025 version while setting the stage for the 2030 version, which is again probably going to be another change in that U factor. So this highlights the industry's future direction. Third-party certification and labeling of these energy performances are expected to streamline into the adoption of certainly the upcoming future editions of the building code. So let's take a look. This is a table based on comparison of typical window thermal efficiencies. So if we take a look at across the top, we can see aluminum frame with a thermal break, a wood or vinyl frame window, or a fiberglass frame window. And we take a look down to the left column, we'll call it the characteristics of that particular window. It's double glaze, clear with air fill. And moving down, double glaze, and down here, triple glaze, and triple glaze rather low E with argon. So we can see in these performance thermal efficiency table, we can see that if we take a look at the ones that I've sort of boxed in red, okay, we can see the R or the U values. And as I mentioned, U values, you want to go to what the lowest number is better performance. But also what I want you to do is think about even a double glazed clear window with air fill. If we take a look at the R factor of 1.59, is not as energy efficient as a wood or a vinyl frame window. And what we can also see from this table is actually the best one in that category is actually a fiberglass frame window. So this can be useful at basically analyzing and taking a look at best at preventing heat loss would be a fiberglass frame window. Now, again, there are certainly other factors that go into it. So that's just talking about a fiberglass frame. Certainly when we talk about the glass panels in it, there also can be certainly some variations. So I just wanted to kind of point that out. Personally, myself, I have some aluminum frame, and I have the majority of my windows are the old wood style wood windows. So I'm probably, my wife would like aluminum because she thinks aluminum's a great solid material. But then we start taking a look at the performance factors. So that's another important thing to look at. I myself would like to go to a fiberglass frame type window, but that's just, my wife and I and our personal preferences as being different. When we take a look at the National Building Code Part 9, these are sort of an overview of the code requirements. So when we talk about windows in particular, there's section 9.6 deals with glass, and it talks about the requirements, code requirements for glass in general. The one that's more specific to our topic today is really section 9.7, and it's called windows, doors, and skylights. And it's basically the section 9.7 is broken down into what's known as subsections. And again, you'll see 9.7.1 talks about general, 9.7.2 required windows, doors, and skylights, and then down to subsection 3, performance of windows and doors. What about manufactured windows and doors? What about site-built windows and doors? And the very last one is all about the installation of windows, doors, and skylights. So as we can see here, if we take a look at this image, we see a little bit of what we call icing or air leakage that's causing this to occur in the cold weather. So this shows the sign of the heat loss, so the upper frame portion of the window. So again, this is sort of evidence that we can see quite visibly. There is certainly air leakage. How well is this window sealed? What's causing this to happen? And these are some of the things we need to think about when we think about installation, and certainly about some of the other factors that the code says that we should be looking at when we talk about windows in general. So let's take a look at some of the performance expectations that the code talks about. So the National Building Code talks about. So again, we go to subsection 9731, except as provided in sentences 2 to 4, windows, doors, and skylights and their components, separating conditioned space from unconditioned space. So condition is the inside, unconditioned is the outside or the exterior, shall be designed, constructed, installed so that when in the closed position they, and you'll see A, B, C, D, E, F here, these are all the performance requirements specified in the building code. So it resists the ingress of precipitation to the interior, resist wind loads, air leakage, so control air leakage, resist ingress of insects and vermin, where required, resist force entry, and they're easily operable when not intended to be fixed. So again, I like to throw some images in once in a while to say, well, again, when we take a look at an existing condition like this, we can see part of this window and we can see a lot of the darker color here on the wood siding with the cladding removed. We've got a lot of water damage in the corner. So we've had some water penetration and certainly some moisture movement between the inside to the outside, or perhaps water from outside leaking in and causing damage to, in this particular case, the sheathing on the exterior building envelope. I also talked a little bit about how do we determine the minimum R value or the maximum transmittance value, known as the U factor. So when we, again, go into the building code, there's a table 936.2.7-A, and it talks about the different zones. And just to kind of give you a very, very quick sort of side reference, if we go over to the right-hand side, we can see what's called a HDD, heating degree days map. And you'll notice that it has zone 4 up to zone 8, and they talk about heating degree days. So the heating degree days is from a baseline temperature. How many degree days do we have to make up for heating? So as an example, if we take a look at the burgundy color areas, mostly the southern part of Canada, in the orange, moving up a little bit above, which requires less or a little bit more heating degree days. And when we move up across the stream, we get up towards zone, we'll call it 7A, 7B, and 8, we're starting to get into that very extreme cold northern temperature areas. So the further north we go, obviously, the more we need better, not just insulation values, but also consideration when we talk about windows and doors. Because again, I call them energy holes because basically they're the weakest part when it comes to thermal efficiency, energy efficiency between basically that outer skin, the outer envelope of the building. So I took an example here. We can see the components, fenestration and doors, so windows and doors, some thermal characteristics, okay, from U values or energy rating. And if we look across the zone and heating degree days from zone 4 and upwards to zone 8, we can see that there are, so what's the maximum U value? Okay, so zone 4, we can have 1.84, but if we move further north, again, we need higher performance U values when we think about the components that go into the outer skin of the building, windows, doors, and certainly the wall system, and certainly foundations and roof system. So I took an example here of Flin Flon, Manitoba, minus 38 Celsius at the 2.5% January temperature. This is taken out of the climate tables, climatic tables of the building code. And it requires a heating degree days of 6440. And if we use basically we take a look at the condensation risk, we take a look at the energy conservation. Again, without getting into all the mathematics and details here, we can see that we can come up with the requirements for a better energy efficient window, for example, for Flin Flon, as opposed to, let's say, I'm down here in Windsor, Ontario, and John's over here in Ottawa, Ontario. And so the further south we go, basically, we don't need as much concern. We still have some concern, obviously, of the performance value of windows and doors. We have less heat loss or potential heat loss. I talked a little bit about window glazing, and certainly we can see often a single panel may have a storm or some type of screen or a combination. A double glazed window, so two panels, space between, may be gas filled. Glass may be low E or a type, some type of argon type gas. And we can see again the triple glazed window. So the main difference is the number of glass panes and gaps in the window. A triple glazing has 3 panes of glass and 2 gaps, which makes it more efficient at heat and noise reduction. But the glazing also depends on other factors such as the quality of the glass and the frames. So we can take a look at it, but we also need to take a look at what is the glass basically characteristics. Is it thinner, thicker? And does that make a difference when we talk about the energy efficiency values? Likewise, we saw earlier, if we take a look at aluminum frame versus we'll call it a wood frame or a vinyl frame, or let's say even going to something such as fiberglass. So again, when we talk about glass, note when ordering windows conforming to CSA A440, so that's one of the window standards, okay? Section 9.7, the local conditions need to be specified, especially if the building's located adjacent to what's called an open terrain. Well, just a little brief explanation. We talk about open terrain. Think about an open area where there's very few, if any, houses that are shielding that house from, let's say, the community in a closer relationship. So again, we have to think about, we have less protection from wind. So again, when we talk about the wind characteristic factor, we have to think about the hourly wind pressures that that particular window or particular opening is going to basically have to deal with. So again, when we refer to the building code, we can see here there's a type of glass, so different types of glass. And we can talk about the glass area in meters square. But we also can see here when we talk about the thicknesses, glass thicknesses in millimeters. So again, I mentioned earlier that we could have something like 1/8 of an inch thick glass, if we want to talk about the imperial measurement, versus something that's a little bit thicker. So again, this also has certain performance values. Certainly, when we think about it from a common sense point of view, the thicker the glass, the stronger that glass should be. So when we talk about this, we also need to think about what's the pressure on that particular panel of glass, on that window. So we take a look at the harmonized standard requires the fenestration products to be tested for a uniform load structure test with the pressure equal to 150% of the design pressure for the wind. So again, I talked about the variations from north to south, also differences in the glass panel, and also differences in the actual framework of the window itself. So again, we're starting to compile all this list of, geez, there's a lot of things for me to think about if I've got to order that window. Let's talk a little bit about low E and argon gas. Well, when we talk about low E, it's virtually invisible metal oxide coating applied to window glass during the manufacturing process while the glass is still hot. It's this film that interacts with the rays of the sun reflecting ultraviolet light. It limits the escape of heat outwards. Argon, or argon gas, is the most used gas in the manufacture of windows because it's an excellent thermal insulator. It thus reduces consumption of energy such as used to heat a room or a space. So again, we have to think about what are we putting between the panels of glass. We also come across another term called thermal break. And what it actually is a thermal break. So a thermal break is a continuous barrier between the inside and the outside of a window frame that prevents the conductive thermal energy loss. So if we take a look at sort of the illustration over to the right-hand side, we're going to assume this could be, well, it could be any type of frame, but I'm going to say for my wife's sake, she likes aluminum windows. She likes this aluminum frame. And if this was a solid panel of window, it would, without this pinkish portion here, this thermal break, we would be able to take the cold air and it would be traveling inwards, or the heat certainly could travel the other way, outwards. So again, this thermal break is really almost we'll call it almost like a plastic shield that helps break, thus create this thermal break between this panel and the outward panel, the inward panel and the outward panel. So again, just simply think as the thermal break is something that's trying to basically reduce the conductive thermal energy loss through that window frame. So a thermal break in a window. I mentioned a little bit earlier about some of the test and certification requirements. Well, actually, there's a number of them recognized within the building code. I've listed them here: CSA A440, the AAMA, the WDMCA/CSA, and certainly the ASTM standard. So when we start taking a look at the test and certification requirements, certainly this goes into manufactured windows. Do they meet the certain testing requirements? So again, another thing we should be looking at when we think about what are we going to do with the purchasing of a window. So again, the lower part here is part of the building code. Again, another table out of the building code, 9733, the maximum U value or minimum temperature for windows, doors, and skylights. So we can see if we again just kind of look at the table, it talks about the component, a window or a door or a skylight. And I'm going to deal primarily with windows and doors for the most part. When it's warmer than -15 Celsius, we're talking about January design temperatures again from the building code, or a little bit colder, -15 to -30 Celsius, or colder than. So we can see again, we're taking a look at the minimum or the maximum or minimum temperature index here. So 2.5, again, we're going further north. It's down to 2.0. We need a better performing window than this one. And certainly this one needs to be better than the previous two. So the colder the temperature, the more thermal efficiency we need to look at in the window. So I guess long story short, if I had to really sum it up, further north we go, we always have to think about the thermal insulation values being the best possible to meet building code. Unfortunately, that's not always the case. But again, moving on, building code 9762 talks about sealants, trims, and flashing. So things like caulking, the trim, the flashing, that we could be trimming a window with some type of wood frame, but basically we'll call it sort of the finishing of the window itself. Okay, so around the perimeter of the window. So the building code talks about sealing compound used to seal the glass components of an insulating glass unit to the sash components shall be compatible with the sealing compound used to edge seal the glass component. Flashing used to protect openings shall conform to articles. And again, the articles are in section 927. So again, we need to think about flashing. And the next one talks about sealant shall be applied between the window frame or trim and the exterior cladding or masonry in conformance with, again, subsection 927. And in unfinished portions of the frame and other components in aluminum windows, doors, or skylights in contact with the edges of masonry, concrete, stucco, or plaster shall be protected with an alkali-resistant coating. So when we take a look at the lower right-hand picture, we can see this is in the almost finishing stages. There's no cladding attached at this point, but I see blue skin. Okay, so this is a nice protective sealant that well seals the window and also protects we'll call it the wood framework. We can see there's a little bit of a flashing that's been put on top of we'll call it the head of the window here. So again, these are things we need to think about. When we go to the upper right-hand one, we can see, okay, so we have, for example, they call it the house wrap, okay? The rigid cap flashing, so the metal flashing, a flashing tape over the head of the window. So this would be considered a flashing tape, your blue skin. And certainly we want a little bit of a slope to run we'll call it the melting water or snow off of the top of the window. So basically, so it's not going to sit here. And flashing tape over top of the window flange. So again, when we start taking a look at some of the details of this, if we go back to the original picture I showed you at the beginning, we were talking about this because they had already started the installation of the windows, and we said, hey guys, what's missing? And they said, yeah, we know. You told us about we didn't put the proper taping and flashing around the windows to protect them. Oh, I guess we need to remove it and do it properly. Anyways, moving on, let's talk about emergency escape openings. What is an emergency escape openings? Well, the building code addresses this life and safety issue as part of what they call a means of egress. Well, a means of egress is basically, how do I get out of a building safely? How do I get out safely? The openings provide an alternative means of escape, particularly when it comes to bedrooms or sleeping spaces in a basement and/or habitable attics in the event of a fire. So what I want you to think about is when we think about this bedroom, or some people don't necessarily call them bedrooms, sleeping space in a basement, how can one safely get out if there is a fire, let's say, at the top of the stairway to the front door to get out of the house? So this is what we're talking about, these, when we talk about windows or openings in those particular spaces, such as a basement. Allows the occupants to safely escape to the outdoors. It allows emergency personnel to enter if it's required. Traditionally, many basements of existing homes have few, if any, acceptable means to exit safely in a fire emergency. So one of the things, again, when we take a look at, I've been into a number of homes where I've inspected where they've created nice bedrooms in the basement, and they called it a 3-bedroom house. They had one main bedroom upstairs and 2 for the kids in the basement. But the windows were so high, how could they escape if there was ever a fire? So you have to kind of flag those things as being certainly, an accident waiting to happen, and hopefully it doesn't happen. But this is what the code addresses as what is your response to an emergency escape opening for those people to get safely out of a house. Another thing we need to think about when we talk about windows and doors is certainly security. Again, the building code addresses this. It talks about what's called resistance to force entry for windows. So this is taken directly from the building code that I basically copied and pasted here. In a dwelling unit, windows, any part of which is located within 2 meters of the adjacent ground level, so basically the ground level grade, shall conform to the requirements for resistance to force entry. Again, looking at it from a point of view of just safety from a forced entry, someone trying to get into or break into. So again, this is addressed also in the building code. Talks again a little bit about egress windows. There are some requirements certainly for those egress windows, except where the suite is sprinklered. Okay, they shall have at least one outside window or exterior door opening from the inside without the use of keys or special tools for them to basically get out. And it describes the window referred to in the sentence. One shall be an unobstructed opening of a certain size. We'll take a look at that in a minute. In a certain area, and maintain the required opening during an emergency without the need for additional support. And where a window requirement in sentence 1 opens into a window well, the clearance shall be not less than a certain size. It shall be provided in front of the window. So again, these are references directly from the building code. And then it continues on with actually articles 4 and 5, where the sash window is referred to. It's got to swing towards the window well. Where the protective enclosure is installed, the well referred to in sentence shall be openable from the inside. So again, just sort of a very brief, we'll call it illustration. So no dimensions less than a specific size of the unobstructed opening for the openable portion of the window. Maximum area, again, unobstructed. And the maximum recommended window height above the finished floor is 1.5 meters or 5 feet. So again, this is just a general requirement, trying to give a depiction of certain width, height, and size in area, so someone other than a very young child can get out the window. It has to be reasonably sized. Again, just to kind of give you a visual, again, we can see here in this particular basement, we have a fairly good sized window that can be opened and basically used as an access in case of an emergency. So these are what we would refer to as those egress windows. A little bit more when we talk about the actual, what about once we get through the window, we need a path or a well that's required for escape or rescue. It must have adequate clearance and access from the inside without the use of tools and keys. We can see here, and again with these on the left-hand side, some of these minimum clearance dimensions. So again, if the window swings in or out, we need a little extra space if it's going to swing out. And again, it should be readily sized and accessible so the person can certainly get through here. It shouldn't be this. This is a nice window well, and hopefully this is not a bedroom or a sleeping space in a basement, because the window is not large enough, and certainly the well's not large enough for the proper escape once, and if they could get out that particular window. Let's talk a little bit now about the installation. So when we talk about the building code again, the installation details of a window or a door, skylights and their components must be appropriately designed and implemented for the building envelope assembly to perform basically acceptably overall. So far, we've covered a number of different protector characteristics: the thermal efficiency, the issues with the frame, the glass, certainly the items of security and safety. So the proper design of the installation detail provides the information necessary to integrate the structure, air, vapor, and moisture barrier functions of windows, doors, and skylights in the overall design of the building envelope assembly. So the construction should be carried out in accordance with these details to achieve an appropriate level of long-term performance. Again, further guidance on installation can be found in the standard CSA A440.4. Again, when we get jumping back into building code, okay, so again, they talk about in point 1 here, the installation of windows and doors conforming to CSA standard. A, shims used to support the windows, doors are permitted to be made of treated plywood. And B, protected from precipitation for walls incorporating windows or doors, or for roofs incorporating skylights in the interfaces of these walls with the windows or doors. And they also shall conform to section 927. The installation of manufactured and pre-assembled windows and doors in skylights and field assembly of manufactured windows and doors shall conform to the manufacturer's instructions. So again, how many people always read the manufacturer's instructions, or even better yet, even follow them? So again, those are important things we need to think about. And the windows, doors, and skylights shall be sealed to air barriers. So again, they're part of that connection, okay, sealed to the air barriers. So when we start taking a look at some of the illustrations here, and this is out of the building code, this is from a website called Building Advisor. And it talks about the installation flange type windows before the sheathing wrap. So we can see here in this particular diagram here, it talks about basically we have the house wrap, sort of this lighter color down here. We have the pan flashing, what I like to call the blue skin, because the one I usually use is called blue skin. And I usually would use this pan flashing, moldable, peel and stick membrane. And basically, this is where I would start, and then basically go all around the window, and at some point certainly install the window. I like to go up all the sides and certainly even the top. Hey, a little more is better protection. I don't have to think about doing it again later, or some of the implications of why I didn't do it. I should have done it. So basically in installing it and then basically resealing it again. So the extra layers of protection. Number one, we're going to be cutting down on the potential leakage, and certainly when we're thinking about this, it's going to be very well sealed. So again, another look from another website, window flashing diagram. So again, installation best practices, and it talks about the different steps. So step 1, the sill flashing, the jamb flashing, the pink. Then we get into the window unit, the head flashing, okay? And basically the flashing termination 5. So the key to success with any flashing detail is to follow the shingle principle, with the upper layers of waterproof materials overlapping the lower layers. So you can see the very last one to go on is in step 5. The very first one is at the sill. So again, well protected. And if we think about that shedding the water principle, if the water does hit it, it's going to run down and basically run past it. So again, we want it well sealed. So installing flashing from the bottom up. So let's do a little quick review here before we almost get to the end of our presentation here. So just a kind of a quick checklist. Look for triple pane insulated glass units. Certainly, not everyone needs triple pane, but if it's affordable, certainly, and if it's certainly required, especially for the extreme parts of northern Canada, triple pane is really the answer. More than one low E coating. Think about argon gas between the panels of glass. Think about that warm edge spacer, so that thermal break and actually the space around it. The frame made of non-conductive materials. So again, my wife likes aluminum. I like, fiberglass. We've got something we have to think about when we replace our windows, but certainly I'm trying to convince her that this non-conductive material, certainly it has a thermal break in those windows of the aluminum frame windows, but as we saw in the tables, they don't perform quite as well as a wood, a vinyl, or even a fiberglass, certainly. And think about the best affordable energy efficient windows that actually you can buy. So when we think about it, certainly we have to think about, there's a cost factor. What is affordable? What's reasonable? And certainly if it's new construction, what meets building code as the minimum requirement? Certainly you can always go better than. Last time when I talked about doors, one of the common themes that we seem to come across is window and glass breakage. Not just in First Nation communities, certainly it seems to be a large problem, but one of our recent findings was a company called Rock Glass that we found out when we did some presentations out in Winnipeg. And this company is actually out in the Winnipeg, Manitoba area about rock glass. So it's becoming sort of, we call it the bulletproof glass for replacement for broken windows. The only downside that we've really found is it is extremely expensive. So again, there probably are other temporary measures, that such as plexiglass, but plexiglass tends to scratch and have, we'll call it some deterioration factors over time. But I just wanted to kind of point that out for maybe people who haven't heard of this product before. It's not an endorsement of the product. It's just something we came across from knowledge shared from some of the other First Nation communities that actually have used it. Again, just to kind of wrap up a few resources, FNNBOA, take a look at our Northern Housing Technical Guides, particularly Booklet 8, because Booklet 8 talks about windows and doors, especially on Northern Housing, in our Northern Housing Technical Guide series on the FNNBOA website. I refer to the National Building Code in the lower right corner here, the National Building Code of Canada. And if you don't have a copy, if you search it out on the internet, you can find it's free. That's the digital version, not the paper version you have to pay for. And I also made mention to the Energy Star. A couple of credits for some of the illustrations. Fine Home Building Magazine. I like subscribing to it. Has a lot of good articles about, better home building. A lot of it doesn't always apply, but there's some good articles that I'm going to come across once in a while and cut out and use. And a few of the illustrations from Illustrated Home, Carson Dunlop, a home inspection company here in Canada. So that pretty much sums up my presentation at this point. I'm certainly open for any questions or comments or feedback you might be looking for. So I'm going to okay.
I don't see any hands up or comments in the chat. We can give it another minute or so.
Yep, no problem.